Welcome to Cognitive Science and Flashcards. So, in science, you're going to have to learn a new set of vocabulary, the language of science. You're also going to need to learn some new facts that you'll have to recall in order to solve problems. So, cognitive science studies how the brain works and how it learns. We're going to use some of the findings from cognitive science to make your studying more efficient and better prepare you for your coursework, so ultimately you can get a better grade in your class because you're learning more. So the purpose of learning is to solve problems, at least in chemistry it is. So you solve problems in your brain and you use information from your memory and from your environment to solve the problems. Your environment includes things like your notes, your book, things that other people tell you, and so on. The brain has a few different types of memory. Working memory, which is the part of your brain where you solve problems. And the length of time the things stick in your working memory is really short, on the order of a minute or so. If you don't think about something for more than a minute or so, it's usually gone. Then you've got short-term memory, information that you remember for just a few days. You've got long-term memory, which is information that you remember for years. So, working memory is again quite limited, but your brain has a huge capacity in long-term memory. So think of this like a computer. A computer has generally a limited amount of RAM, or random access memory. You've got, let's say, in a general computer nowadays, you've got something like 8 gigabytes worth of RAM, but you have much more memory in your hard drive. The hard drive has maybe 500 gigabytes, maybe a terabyte worth of memory. So you've got easily a few orders of magnitude more memory in the hard drive than you have in the working memory, the RAM. The catch is that the RAM is significantly faster than the hard drive is. So your brain works largely the same way. In your working memory in your brain, you've got a relatively small capacity, but that's where you actually work with the information. Your long-term memory has a remarkably huge capacity. In fact, it's even larger than the hard drive in modern computers. So, the goal of learning in any subject, not just in science, is to move information from short-term memory into long-term memory. So, in short-term memory, you're remembering it just for a day or two, or a few days. In long-term memory, you're remembering it for months, years, decades. So, you can then later move the information from long-term memory into working memory in order to solve a problem. It's not lost from your long-term memory, right? When you access the memory, you're duplicating it into your working memory, and then later it gets thrown away by your brain. Okay? But it's still there in your long-term memory. And that's the goal, is to have stuff in our long-term memory that we can call up whenever we need it. If, however, you don't move the information into long-term memory, then you haven't really learned it, and it goes away in a few days. Which means, in other words, studying the night before a test is a bad idea. You may be able to stick it in your short-term memory for a little while. You may even be able to pull it back into your working memory for that following day's test. But then on the next test that you have, it's going to be gone. So what you need to do is move it from working memory into short-term memory, and then from short-term memory into long-term memory. And once it's in your long-term memory, it should stay there for a really long time. It should stay there for the rest of the course that you're in now. It should ideally stay there for the rest of the time that you're in college. It should stay there for much, if not all, of the rest of your life. So if you're going to need this information later on, instead of just to pass tomorrow's test, if you're going to need this information, you really need to commit it to long-term memory. So the information may stick in your short-term memory long enough for your test, but then on your later tests, that information will be gone if you just stick it in your short-term memory. So again, we want to put it into our long-term memory. So learning requires repeated thought about the meaning of new information. Practice at recalling new facts and using new skills that is timed in ways to encourage the brain to move new information from short-term memory into long-term memory, which means you have to come back to it over and over and over again. If it's not repeated thought, then it doesn't get into your long-term memory. So, cognitive science provides us with a few helpful principles for learning effectively. The first is that learning is cumulative. Experts in a field are able to learn new information very quickly because they already have a long-term memory storehouse of knowledge about information connected to the new information. You must develop a similar storehouse over time with lots of practice. So for me, learning new chemistry knowledge is relatively easy because I have a lot of other chemistry knowledge to connect it with. If I were, however, to try to learn something else that I don't have much experience about, I don't really have anything else to connect it with, and so I'm going to have to spend a lot more time and a lot more thought and effort on synthesizing that new information and integrating that new information into the worldview that I already have. So, cognitive science also tells us that learning is incremental, which means that learning is done in small pieces. For an unfamiliar subject, there's a limit to how much new information your brain can move from short-term memory to long-term memory in a short period of time. That is, many small study sessions are going to be much, much better for you than fewer long study sessions. In other words, slow and steady wins the race. Study for 20 minutes at a time, then take a break. And then study for another 20 minutes and take a break. And a few 20-minute sessions, totaling roughly an hour a day, is probably about what you want to be hitting for each of your classes. So an hour a day for each of your classes should get you where you want to go. On the other hand, if you put off studying for a class until the night before the test, and then study in a giant 6 or 7 hour chunk of time, number one, it's going to be really difficult for you to do, and number two, you're not going to be learning as effectively, so you're going to end up not doing as well. Your brain can do parallel processing. So while adding information to your long-term memory is gradual, your brain can work separately on remembering what something looks like, where you saw it, what it sounds like, how you say it, how you write it, and what it means, all at the same time. Each cue is associated with a different sense and can be triggered and can trigger the recall of that information. So the more ways that you try to learn something, the better. The more ways that the more senses you involve, or the more ways that you try to incorporate some knowledge into your brain, into your long-term memory, the easier it's going to be. Because the more pathways you'll have of getting that information into your brain, and then the more pathways you'll have of getting that information out of your long-term memory and into your working memory so you can solve the problem with it. So, when learning new information, listen, see, say, write, and connect it to other information that you already know. This is what you have to do, right? You may be listening to me and seeing it on the screen here, but you should be saying it. You should be writing it. You should be connecting it to other information that you already have. So make a mind map, or draw out a picture or a diagram, or whatever way works for you, flashcards, that sort of thing. So the working memory in your brain is limited. Again, the working memory is where you think. So let's try multiplying 612 by 246 in your head. Do you have the answer yet? Now let's try multiplying 612 by 246 with a pencil, paper, and your head. I bet you can do it now. It may take you a little while, but you can do it. You have the math skills to multiply these two numbers together. But it's much more difficult for you to do this in your head than it is if you use a tool like a pencil. And that's because your working memory is limited. It's just too hard to store all that information in there and work with it at the same time. So, manipulating multiple pieces of new information in your head is difficult, because your working memory is relatively small. Learning stepwise procedures, or what we call algorithms, is one way to reduce this cognitive load when problem solving. If you know what to do, then you just have to go ahead and do it. You're plugging in new numbers. You're just applying this algorithm to a new problem. One of the sayings in cognitive science is automaticity in the fundamentals. This is another way to overcome the limitation of working memory. Information that can be recalled automatically from our long-term memory into our working memory does not tax the working memory nearly as much as does new information that we have to put in the working memory. So, if you can recall knowledge automatically because of the repeated practice that you've done, then more of your working memory is available for higher order thought, higher level thought. Concepts are crucial. Your brain constructs a conceptual framework to categorize knowledge being learned. So this allows you to recall facts and procedures when you need them. But your brain only tends to store information that is in agreement with your conceptual framework of how things work. So if you have a more complete understanding of the big picture, then your brain is better able to judge which information should be used to solve a problem. And thus, you can better put just the required information into your working memory. So, learning concepts does not replace the need to move key facts and procedures into your long-term memory, but it does help you store, recall, and apply the knowledge that you already have in your long-term memory. You can always look it up. Is a poor strategy for problem solving. Because your working memory is limited in how much information it can handle, the more information you have to look up, the less likely you are to follow your train of thought from the beginning to the end of a complex problem without making mistakes. You're going to get lost somewhere in the middle and go, I don't know where I was, where I am now, I don't know where I started, I don't know where I'm going, I don't know how to do this. And you're going to end up spending a lot more time doing these problems during the problem-solving phase than you would have if you had spent some time memorizing instead. So, how can you move information into your long-term memory? Practice. But some forms of practice are more efficient than other forms of practice. So, use some of these techniques to help. One technique is overlearning. If you practice recalling new information only until you can recall it perfectly once, you'll tend to remember the new information for just a few days. But if you practice recalling perfectly repeatedly, over and over and over again, you will tend to remember this information for years afterwards. And that's your goal. You want this information so deep in your head that it's never going to come out. Right? You want that information in there, and you can just automatically pull it back whenever you need to. Another technique is the spacing effect. So studying 20 minutes per day over 3 days is more effective than studying for 1 hour one day. If you study something every day for 3 or 4 days, and then revisit it once a week for 2 or 3 weeks, and then once a month for 3 or 4 months, you're pretty likely to remember it for decades. Experts in a field almost always attribute their success in that field to hard work over an extended period of time, rather than to talent that they were born with. Don't get me wrong, talent helps, but anybody that is a recognized leader in their field always has to work hard at it as well. Talent only gets you so far. So becoming an expert in a field, generally, it's relatively well known that becoming an expert in a field requires roughly 10,000 hours of practice. That's 4.8 years of practicing, 40 hours a week, 52 weeks a year. And this is why studying some subject in college takes about 4 years. Because you're getting pretty close to being an expert on that subject. Right? You're going to spend a lot of time thinking and working with that subject, with knowledge and techniques and skills in that subject area. Now, I don't expect you to become an expert in chemistry. But how about 1% of an expert? You should be able to become 1% of an expert in a chemistry course. And if you practice chemistry for 1 hour a day, 6 days a week over the course of a semester, you'll be at about 100 hours of practice. 100 hours is 1% of 10,000. So that seems reasonable for you to get to be 1% of an expert. So for my classes, you should be spending about 1 hour a day. For everybody else's classes, you should be spending about 1 hour a day as well. So, core skills. You should practice most often the skills needed in the discipline that you're interested in. So for chemistry, these are things like unit conversions. These are things like knowing the structure of atoms and molecules, understanding how these things are put together. You need to get a good night's sleep. While you sleep, your brain decides what information to store in long-term memory. If you don't sleep enough, then studying more is pointless because you may be getting that information into your short-term memory, but if you're not sleeping enough, then that information does not move from your short-term memory to your long-term memory. That transition of moving from short-term to long-term happens mostly when you're asleep. So you have to get a good night's sleep every night. A good night's sleep just one night before the test isn't going to be enough. And again, cramming the night before the test is a really bad idea. You should be spreading your studying out over weeks before the test and getting good sleep for that whole time, those weeks before the test. So all of these add up to this. Study repeatedly, including reviewing information that you've already learned in the past few weeks and months. You should practice a little bit each day, about an hour a day, and you should be getting plenty of sleep. I guarantee that if you do all of these things, you'll do well in virtually any class that you take. So, which is more important in learning? Knowing the facts or knowing the concepts? Well, cognitive science shows us that both of these are necessary. You need to understand the concepts, but you also need a storehouse of facts in your long-term memory so that you don't overload your working memory when you're doing the problem solving. So to help master the fundamental information, you should make some flashcards composed of two types. One-way cards for questions that make sense only in one direction. And then two-way cards for facts that you need to be able to recall in both directions. So, while you will eventually need something like 100 to 200 cards, you can start with about 30 3x5 inch index cards, and on 12 to 15 of them, cut a triangle off the top right corner, and these are going to be the one-way cards. So, you're always going to keep that notched corner on the top right. You could choose the top left, it doesn't really matter. Just be consistent with whatever you do. The front is then the side with the notch at the top right. The back is then the side with the notch at the top left. So fill in the front and back of the cards as shown in the table on page 37 of the textbook. And if there are any multiplication or division facts up to 12 that you don't know instantly, which means if you don't know your multiplication tables up to 12, then you need to learn them. You're going to need to know these, right? So add those as well if to your information from page 37. And then you can make two-way cards for the information in the tables on page 38 of the book. And again, these are the ones that you need to know in both directions. So you need to study these cards in both directions for the two-way cards until you can recall all of them perfectly. And I recommend practicing with just one of the types of cards at a time. So go through your one-way cards a few times, then go through your two-way cards, take a break, then come back to it, go through your one-way cards again, go through your two-way cards again. You need to keep doing this until you can recall each of the answers perfectly, without making mistakes. If you make a mistake, you need to come back and hit that one again. So for one-way cards, if you get a card right quickly, put it in your got it stack. If you miss it, say the content, close your eyes, say it again. Say it a third time, and if necessary, write it a few times. Then go back and return the card to the bottom of your do it stack. Practice until every card is in your got it stack. For two-way cards, do the above steps, first in one direction, and then go back, flip the cards over, and do them again in the opposite direction. Master all of your cards at least once, and then do some practice problems for the textbook. And then for the next 3 days, don't take any days off, repeat the above steps. So go through the one-way cards, go through the two-way cards in one direction and the other direction. If you've made any mistakes, put that card back in the do it pile, say the content on each side, write it down if you need to. If you find that you're making a mistake on something on the second, third, fourth day, you really need to do some additional work with that one. You need to write it down. You need to say it. You need to practice with somebody else. Get somebody else to quiz you. Repeat this again before working the practice problems, again before your quiz, and again before your midterm or final. And then revisit these cards every week for the next month, and every month for the remainder of your time in a chemistry course. You should be able to go through these really quickly once you really have them in your long-term memory, because you'll pull it up, you'll take a look at the card, and you'll know the answer immediately. You'll say it out loud, you'll move on to the next one. And you'll be able to go through these really quickly. So make new cards for each new topic, make them early, before watching the video on a topic. So I recommend reading through the book, taking a look at the flashcards, make the flashcards, try memorizing them a time or two, then watch my video. So mastering the fundamental information will help in understanding the video, understanding what I'm talking about in the video, so that once you have the information in your head, those fundamental knowledge and facts, once you've got those facts in your head, then you can try to connect them with the concepts, with the ideas, and merge them in with other things that I'm discussing in the video, and that will help your learning. So keep your cards together with a rubber band and then carry them with you. I recommend practicing during your downtime. So if you get to your classroom and you've got 10 minutes before class starts, pull out your flashcards. Whether or not it's a chemistry course, doesn't matter. Pull out your flashcards, start going through them. You don't have to get through all of them, but get through however many you can, and when class starts, put them away. So if you have multiple colors, then this can help. I recommend changing colors after a few chapters. This can help you stay organized for what material you really have mastered, because that's 2, 3, 4 chapters ago. So naturally, you should modify this system as works for you. But if you follow these steps, it will improve your learning and thus your academic achievement in any class. So you're best off using multiple strategies to learn. Use numbered lists, mnemonics, phrases that rhyme, flashcards, reciting, writing information down, and so on, right? Any technique that you can think of, any technique that you like, use it. Right? If you want to practice with a friend, quizzing them with flashcards, or having them quiz you on vocabulary words, or whatever. Any way that works for you is fine. Just make sure that it's actually effective. If you get to a quiz and you don't do so well, then you know that something was wrong with the way that you were studying, and you need to change it. Otherwise, you're just going to get the same result later. So, practice using these repeatedly, spaced out in time to give your brain a chance to absorb the information. Again, you should be spending about an hour a day. Go through your flashcards once a day, and that should be fine. You're going to have to do this over a significant number of days. It's not going to work in just 1 or 2 days. But remember, you have to sleep so the information gets stored in your long-term memory. Sleep is when your brain moves information from your short-term memory to your long-term memory. So you've got to get enough sleep. For more complex information, then you may need to write out a chart showing the patterns amongst various bits of information. And this will help you connect that complex information, that complex idea, to other ideas that you already have stored in your long-term memory. So that was cognitive science and flashcards.